Hello, everyone. How are you? Hope you like the previous topics. Seems interesting. So today I'm going to talk about multi-armed bandits. We'll call it MAP, and make another small contribution to spreading faith in Saint Base, if you know one. Usually this sect includes ML engineers and data scientists who have become bored, but in fact there are several extremely powerful tools and underestimating tools, map one of them. First of all, let's get to know each other a little bit. My name is Pavel, and first of all, I'm a mathematician. Second of all, I'm a product person, startup enthusiast, and data consultant, and a lover of global markets. During my career, I have come across a lot of places where maps could be used, but were not used for fear or complexity or misunderstanding by business owner. However, in some project, I have successfully managed to implement it, which I will tell you about today. A little bit about structure. In the first half of the presentation, we'll talk in general about map, definitions, intuitive understanding, comparison map testing with the A/B testing. In the second half, I will tell you more about the case from the game dev industry and share some practical considerations that may help you to implement map in your companies, your project, in order to increase profit, revenue, whatever. As you could already understand, there are slightly two different entities, multi-armed bandits and testing with the help of multi-armed bandits. While the second is kind of a knowledge of A/B testing, the first is the numerical algorithm for making decisions. Let's talk a little bit about this algorithm, which leads in the foundation of our testing. Imagine you are in a casino with multiple slot machines, each providing several different rewards, and you don't know which machine offers the best payout. So you might decide between playing machines that seem to be the best reward, exploitation, or trying other machine to find a potential better payout, exploration. But what does it mean? So if we imagine that each machine or arm returns some number that we need to maximize or minimize, then we can also imagine that we can build a distribution from these numbers. If we have a general distribution, then we can easily solve our task. But the problem that in order to build a distribution in the real world, we need data. So we will have to ask each machine to give us a number and do it enough times. This is called exploration, to build distribution, actually. On the other hand, another arm, exploitation is asking for a number, the most efficient arm, in order to farm good values, maximize our profit, actually. So mathematically, we can describe it like this. Values, numbers are usually called as a reward from ARM. Time also plays a significant role here. Distributions are. In ideal world, we'd like to be able to explore the best ARM are very quickly, and the rest of time just get the best reward from this ARM. To understand how it works, let's look at the simple example. The simplest example, Epsilon-greedy, multi-arm bandit Epsilon-greedy algorithm. We will set a rule that with a probability 90%, we will realize the best arm, and with a probability 10%, we will explore other arms and build distribution. So coin toss as usual. If it's that simple, then there must be a disadvantage, right? So they are. And I would highlight two key drawbacks. The first is instability of the solution. Since epsilon is fixed, system could not be robust. It is very difficult to fine-tune for each case. And if you slightly change it to one or another direction, we'll immediately lose in general reports. The second is bad performance in cases of non-stationary systems. That means if the distribution arms change over time, which happens very often in real life. Let's say arm number 3, which used to be unfavorable, began to give a lot of rewards from some point. And Epsilon-greedy may not be able to cope with the decision that we need to switch to this third arm. And the convergence rate, of course, will be terrible. Just take a huge amount of time. So we briefly discussed about algorithm that is under our testing. As you might have guessed, testing in groups is somewhat similar to the return of rewards from your arms. People have some metrics and they perform either better or worse. So yes, it seemed that it is possible to draw an analogy and build a good stable system. I will give a definition as nobody does in textbook with the pictures. A/B tests, A/B testing. We divide the audience into groups, look at metrics based on test results, and roll the best group to the entire audience. Everything is simple. Map testing. We start with the same number of people in the each group, but their shares begin to change depending on metrics, rewards. The rollout here may not be complete, but simply a state of which 95% of audience is the group with the best metric, and 5% we need to reserve for explore potential changes for the rest of groups. The time for rolling out can be called at the time map convergence to the ideal state of the system. This parameter, as well as fairness, very much depends, obviously, on how we set up a combination of exploration and exploitation. And an attentive listener may notice that the implementation of map testing requires infrastructure for reshuffling users in test groups. Hence, of course, from a business point of view and from technical point, not every test suitable for map algo. So do not forget about classic A/B testing as well. Let's take a short break from learning this topic further and summarize why the map algo might be good. There are a lot of bullet points, but I want to highlight two of them. First, real-time adaptation. I have already mentioned that in the real world, out of test environment can change. And for example, due to different traffic buying, the second arm will perform 2 weeks better than 2 weeks worse. And however, the map structure allows you to give first preference to the arm 2 and then to another arm, for example, third arm. If you really will see the significant improvement in third arm distribution. The second is reducing opportunity cost and downtime. If you are a small company or the testing is very important for you, then the poor result in couple of groups during A/B test can significantly affect your monthly payout. So for A/B testing, it is very simple. For map testing, sorry. If the rewards are initially terrible, then the number of people in these groups will drop to the very minimum already in the first week or second week. I can say about cons as well. If we sum up all stuff, the first one is complexity. The difficulty lies in the technical implementation, in understanding what's happening, in the mathematical implementation. All these increase the chance of making a mistake and losing money. And the second obvious disadvantage that it's not all hypotheses can be tested with the map. For example, in tests where interaction takes a long time, if you test customer support in a complex service, for example, where chats can continue throughout several days, you cannot reshuffle every specialist every day. Or a classic example with testing taxi drivers. Frankly, A/B testing doesn't outperform map testing even in time duration. For good cases, the convergence rate of map can exceed A/B by 2-3 times, but you need some data for it. But of course, I don't think that you need to test the color of the button on the landing page using map. The implementation and explanation to stakeholder will take longer and more expensive than the effect of the entire test itself. So yeah, it's necessary to flexible choose the tool the best suited for every use case. I really like few examples where map is ideal not only for testing, but also in general for the concept of product life and production version. In an e-commerce company, map can be used for dynamic pricing and personalized offer. Retailers like Amazon employ map algorithm to adjust product prices real time on the customer behavior, demand, competitor price, etc. It also can be realized actually out of the box in multi-arm bandit with a contextual feature. We will talk about it a bit later. My favorite use case here is medium buying and traffic allocation. By design, leads and prices change over time due to advertisement auctions and the variability of market conditions. That's why it's so ideal to use a map for dynamic learning on new data and real-time money allocation to different media sources. Let's imagine ourselves as the owner of game studio. You recently released the game, let's let it call Farm in Space, and you and your debit and credit do not match. In other words, there is not enough on LTV tests to recoup your marketing traffic. Let's also assume that the marketing department is working full capacity and there is no longer room to optimization in marketing department. Like any decent mid-core game, you have a shop with prices, offers for the events, subscriptions to the battle pass, and included down the list, etc., etc. Your gut tells you that just raising the price of all product will be wrong decision for two reasons. Firstly, your audience is too different, and someone may not like that that you increase price. The man could churn. Secondly, you are very afraid to the drop of the retention in general due to the fact that you do not yet have a dedicated audience. Let's say we just launched the game and more or less all your clients, all your gamers are newbies. And then you have a hypothesis, changing the price, not for an integral audience, but for some segments where you think there is a place for better utilization of gamers' money for Crystal than now. That is risky project because it requires a lot of tests online. So you definitely don't want to lose a lot of money of the players on the players themselves. So you need to reduce opportunity cost and draw down. And second, you are constantly testing different traffic buying and clearly understand that different people will come from different media channels with different economic opportunities to buy your crystals. So you need a tool that can adapt to change, adapt to changing condition. Of course, meet map. The plan is can be split in few steps. Analytically determine the place where we can earn the most. Together with a game designer, identify the right segments and price strategies for them. For the further fine-tuning, develop possible trackers, players' behavior, their activity, and so on. And finally, make a map to calibrate our prices. Tricky moment here to maintaining balance of money and quality. Therefore, you need a careful look at the metrics and test for a long enough time to detect churn of players. Just the same as the classic A/B testing in game dev or other industries. Let's go through each point in more details. First, I want to share a good indirect sign where optimization may be needed in your game. To do this, you need to remember a little bit about economy and what price elasticity is. As a creator of game, you need to understand what kind of economy is embedded in your game. So, for example, most likely few players buy large parks of crystals, but these are whales that brings huge share of revenue. At the same time, an average player can buy an offer for $1. There are clearly more amount than whales. And now let's figure out what the elasticity curve will be in India if your store tailored in USA. That means your store by design quite expensive. The answer is a curve with any behavior other than you expect. So it may be that the price is suitable only for a very rich audience and the curve will turn into a straight line, or vice versa. The price of expensive offers is too expensive, and no one buy them. Let's imagine we realized that we need the regional prices, and we need to adjust them adaptively depending on traffic. To simplify, let's say we have 3 arms. Talk about segments. What is it in general? From the technical point of view, there are different prices with different amounts of crystals in our store, which are integrated with the Play Market and App Store payments. From the business point of view, this means 3 groups of players with a completely different economic data. In other words, you are working with a game designer on the internal value, instinctive value on the crystal for each offer and in each group so that they correspond the possible economic ability of the gamers, for clients. From the mathematical point of view, as a result of our testing, these cohorts should transform into groups. And these groups must be more homogeneous across payment characteristics and stable from the point of view our algorithm. It means that reshuffles stabilized and group size more or less same size. So, for example, we'll understand that the current US prices for UK country are suitable, but there is a segment of players who feel better with a lower price. Now, let's talk about algorithm finally. Thompson sampling solves the multi-arm bandit problem by applying my favorite Bayesian approach. It is iterative algorithm that maintains a probability distribution for each machine's expected reward, and representing our uncertainty about the true general reward distribution. At each round, the algorithm samples from this distribution, and instead of probability epsilon approach, select the machine with the highest sample as the action to take. So any arm can be chosen, but the best arm gonna be chosen with a more chance. Or it also depends what is best, because distribution might be really, really different. First step, initialize prior beliefs. That means that at the beginning, Thompson sampling algorithm initialize a prior distribution for each machine rewards. Typically, if you have a non-informant prior, you're picking for normal distribution, beta distribution as a prior, and assuming equal probability for all possible rewards. Second, in each round, our alga samples a reward value from each machine's distribution. The machine with the highest sample value chosen, and the lever is pulled. Third, after the selected action is executed, the algorithm observes the actual reward obtained from the machine, and then using the observed reward, we update profitability and probability and profitability distribution, posterior distribution, for the selected machine using Bayesian formula. The updated distribution becomes the prior distribution for the next round, and repeat it until some time or until stabilization. Okay, but you may ask why I collect data on user behavior back then, and I will tell you context. It turns out that the map algorithm can rely not only on rewards that it returns from ARM, but also on other information about user. In simple case, let's put a one-dimensional metric vector of game live ops that will talk about the number of purchases on some offers, depending on event taking place in the game. For example, Halloween, Christmas, etc. And voila, accuracy and speed of convergence will already improved. And interestingly, that from this point, our multi-arm bandit can learn. And the better our context guesses the reward that the bandit will receive, the better the optimization quality will get. So for example, we can use table value of user behavior to predict next purchase, and it should, if the predict is good, and our reward matches, for our alga, it will be easier to learn and stabilized. This is also gives a rise to the idea of the main internal quality metric, regret. And the main idea is to don't regret your bad luck that you could do nothing about. You regret your bad choice that you could have done something about if you only knew. Very philosophy thought, I know. But the idea is that the better we choose the prior distribution for our arms, the better context tell us which arm will give the most money, the better predictions we have. The less cumulative regret map we'll have. And what happens in the end? Before launching this beast in production, I strongly advise you to backtest on syntactic example that you expect online with more or less same data. Here's the result of regional price in one game. While the purchase of traffic was changing there, and it is a vivid example. In fact, production version lasted longer for sure, but I normalized it is for convenience. So if initially we had 1,000 people, on the 13th day of the test, when the group had already stabilized, other traffic began arrive abruptly. Let's say poorer and another arm 0 began, cheaper arm. On the 18th day, traffic changed again. Expensive media leads of a paying audience started to play, and the price at the game store had to be changed again. ARM 1 and ARM 2 1 that time. And as a result, the churn rate has not changed in 100 days, and the RPU in the country has increased by average 20% compared with the second ARM, which used to be production before. And we can also ignore the trick of the marketing department and enjoy optimizing out of the box for different types of traffic. So overall, want to thank you, Terricon Value, and the audience for the opportunity to talk about the topic, and warn against using mathematics other than the simple arithmetics. The more difficult it is, the easier it is to make a mistake. So, for example, many articles are written on map, and sometimes people may complicate this concept very much without strict benefit. Therefore, always think with your head, and thank you for attention.
Thank you.
Thank you, Alexey. We haven't a question. Okay, the next speaker, Artyom, please.
Hello, everyone. I need to show the...
Thank you. The next speaker, maybe we have a question. No? No. Thank you. The next speaker, Pavel, please.
Yes, hello.
Hello. You can demonstrate.
You see my presentation, all good?
Yes, all good.
Okay, nice. Hey, hello.
Thank you very much, Sergey. They're great presentation. Maybe question in our chat. No, we haven't. Okay, thank you. Well, we meet the next speaker. It's Ilya. Ilya.
Hi again.
Here. Okay.
Maybe I'll try share